Okay, in this presentation we're going to look at a probability question. So this is an insurance theme again. So consider an insurer that offers two types of policies. We have home insurance and car insurance. Okay, so 70% of all customers have a home insurance policy and 80% have a car insurance policy. Okay, so each customer must have at least one of the two types of policies. Obviously, otherwise they wouldn't be customers. But just worth saying. It just suppose that they did not say that. Just that might be a trap in an exam question. Just to sort of say, what is the probability that they're neither? And you're not really given any of the information, but you just sort of assume zero because they wouldn't be customers. That would require a bit of lateral thinking. Anyway, I digress. Calculate the probability that a randomly selected customer does not have a car insurance policy, has insurance and home insurance, car insurance and home insurance, has home insurance, probability that they have home insurance given that they have car insurance, that's conditional probability, and that they do not have car insurance given that they have home insurance. Okay. So this is going to exercise us quite a bit with regard to conditional probability. So just as a quick remark, I sort of made mention of that already, that the probability that they have one or the other is 1. Okay, that they have either a car or a home, otherwise they wouldn't be customers. Okay, so the probability that the person does not have car insurance is the complement of the probability of them having car insurance, which is 1 minus 0.8, which is 20%. That's really a straightforward one, really. We're told that here, so it's really just a straightforward one to get us started. So the probability of car insurance and home insurance, in case you're not familiar with this notation here, that's intersection, but essentially means car and home insurance. So that's the probability that they have car insurance plus the probability that they have home insurance minus the probability of both. Okay, now sorry, just actually what am I doing here? This is the addition rule. Okay, but it is just that the intersection and the union are in reversed roles, which is to say you typically see this element over here and you typically see this element down over here. Okay, but essentially both variations are correct. It's usually that you would sort of usually see the union here and the intersection sign here. So this is union, by the way, and that means or, car or home or both. Okay, now so that's straightforward enough. It's just a sort of, that's the addition rule as they call it, but it is just in the the rule that sort of defines the relationship between the intersection and the union, and it's in a slightly unusual format, but it's straightforward enough. Okay, so the next question is, has home insurance given that they have car insurance? So this is a conditional probability question. Okay, so essentially what we're going to do here is use the conditional probability formula. I won't write it out, but just a remark to say that what is the probability that they have home insurance given that they have car insurance? That would mean that whatever is on this side of that bar, given that, okay, you'd verbalize that as given that. That should be in the denominator. Okay, so that is equal to the probability of car and home insurance divided by the probability of car insurance. Okay, so this is what we worked out in part B, that it's 0.5, that's car and home insurance. The probability that they have car insurance is 80%, 0.8. So we're dividing 0.5 by 0.8 and we get 0.625. Okay, and finally, so this is a long question, or not a long question, but it just needs a little bit of extra thinking. Okay, so we're asked what's the probability that they do not have car insurance given that they have home insurance. Okay, now, so in the first instance, this is the formula that we would use. Okay, and my brackets are all over the shop here. I apologize for that. Okay, and anyway, so probability of the complement of car C, let's say, given home is the probability of car C and home divided by the probability of home. Now we actually know what the probability of home is. That's 70%, 0.7. But we need to find this expression here. Probability of car insurance and home insurance. Okay? Now this just requires a little bit of lateral thinking here. So essentially the probability of home insurance can be broken up into two, it can be decomposed into two events here, okay, which is essentially we can divide the homeowners into two categories: those who do not have car insurance, okay, this group here, and those that do have car insurance, that group there. So it's like sort of separating our homeowners into two groups and trying to figure out the probability of being in each of those two groups. Okay, so we know 70% are homeowners, and we know that 50% of are car and homeowners. Okay, so let's say 7 out of 10 are homeowners, and 5 out of 10 are car and home policy homeowners, home insurance policy owners, I should say. But essentially what I'm going to do, just remark upon, is that we're just that formula there that I have highlighted here. That should be straightforward enough, really, when you just sort of think about it a bit. And what I'm doing here on the second line is just rearranging it algebraically. Okay, so this is directly equivalent to the formula that's just above. It's just reworked. Okay, so what I'm going to do, and we know what P home is because we're told it, and we've worked this out earlier, 0.5. So we know this to be 0.2. So 0.7 minus 0.5 gives us 0.2. So this is where this 0.2 comes from, here. And we know probability of home is 0.7. So 0.2 divided by 0.7, that gives us 0.2857. So that is the conditional probability of not having car insurance given that they have home insurance. All right, we'll leave it there.